In this arbitration field, the last bit present is called as RTR bit. So in the data frame is the frame which contains the data. This RTR bit is always 0. And in the case of frame, RTR frame is the one which consists of request for the data. So in this case, this bit is always 1. So this point you can note. So this 11-bit identifier, it is based on CAN2A. If it is CAN2B, then this identifier would be 29-bit. Coming to control field. So it consists of 6 bits. The first bit is an idle bit, that is identifier extension bit. This bit is used if CAN bus 2B with the extended identifier format consists of 29 bits is desired to be used. The second bit, R0, is reserved for future use and its status is of no use to us. This is control field, this is identifier bit. If we are making use of CAN2B, then this bit is used. This is reserved for the future purpose. So now this DLC bit, it consists of 4 bits and it represents the number of bytes that are present in the next field, that is data field. So this tells you the length of the data which is being sent on the bus. So there can be a minimum of 0 bytes to a maximum of 8 bytes that can be sent as data in a CAN frame. So this gives you the length. Suppose if you are sending 2 bytes here, 0 to 04, then this DLC would be 2. So this tells you the data length. So control field DLC, so it can be from 0 to 8. So these are the different combinations that are possible for DLC. Now coming to data field. So data field is the field which will contain the actual data, the sensor data or the actuator data or the data being requested or sent. So the actual information would be contained in this data field. So it can consist of byte 0 to byte 8. CRC field is a 16-bit. This field is used to calculate bit errors present within a CAN frame. The CAN controller does this operation automatically. There are a total of 16 bits present in this field. Of this, the value of the bits in the first 15 fields are automatically calculated. The last bit is called a CRC delimiter and is always recessive. So CRC mechanism is used to make sure there are no errors present. So this CRC calculation is automatically done by your controller. So the first 15 bits, it is being calculated by your controller, and the last 16th bit is always recessive and it is called as delimiter. Now acknowledgement field. This field is 2-bit long. It consists of ACK slot and the ACK delimiter. The ACK delimiter, as is the case with all delimiters found in a frames, is always recessive. So in the case of CRC delimiter, it was recessive. Same case in the case of acknowledgement field, this ACK delimiter is recessive. So for all delimiters, the value is recessive, that is 1. So the node that transmits a frame transmits ACK slot is recessive. So the transmitting node, in that the ACK field would be 1. The node that receives a frame successfully reports this to the transmitter by sending a dominant bit in the ACK slot 0. So in the case of transmitter, the ACK slot is 1. In the case of receiver, the ACK slot is 0. And delimiter, as we know, it is always 1. The end of frame. So this is the end of frame. It consists of 7 bits and these 7 bits are always recessive. So it consists of 7 recessive bits. Coming to intermission. So this consists of 3 bits, and all these bits are recessive always. An intermission field is present in between consecutive data frames and RTR frames. So this is used to distinguish between two frames.